PS5 Pro lead architect Mark Cerny unveils codename Amethyst ML collaboration with AMD. Ahead of the launch of the PS5 Pro last month, Sony invited as part of a very select number of media outlets and analysts to get an early look at the console and a soon-to-be-released deep dive into the system architecture by none other than the lead architect of the console, Mark Cerny. The event also included an exclusive candle with Mr. Cerny himself afterward, which you can read here. Mark Cerny started off the presentation as a sort of bits and bytes talk to principally focus on the GPU for the PlayStation 5 Pro and why it matters. As it's been some 7 years since the beginning of the PlayStation 5 journey, it's been more than enough time for the technology advances to need that additional power to make the most of the console generation. With the PlayStation 5 already having been on the market for more than 4 years, Mark Cerny admitted that it's taken time for game creators to get up to speed, unless you're one of Sony's first-party studios like Naughty Dog or Sony Santa Monica. Much of the PS5 Pro presentation focused on what Mark Cerny called the Big Three: a larger GPU, advanced ray tracing features, and upscaling games through artificial intelligence and PlayStation Super Spectral Resolution, or PSSR. The first focus was on the larger GPU present in the PlayStation 5 Pro, which features a unique AMD architecture that Sony was branding as Retina 2.x. This was a hybrid variant of RDNA 2 while featuring both custom and future RDNA versions present in RDNA 3 and beyond. This is combined with a GPU that featured 66% more workgroup processors, or WGP, compared to the graphics solution present in the existing PlayStation 5. Sony wanted to emphasize that they decided against fully upgrading the system architecture to RDNA 3 because they did not want to have two separate game packages or versions between the PlayStation 5 Base and Pro models, not unlike Microsoft's Xbox Series S and X solution. Secondly, Sony made a point of refuting the 335 teraflop number that was present in the lead-up to the PlayStation 5 Pro's launch. Mark commented that it would have been a nice bonus to have twice the flops, but it wouldn't double the real-world performance and would have instead led to something he dubbed flopflation. He once again reiterated the increase from 18 WGPs, workgroup processors, or compute units, to 30 WGPs while also introducing 67% higher flops. In terms of real-world gains, this meant upwards of a 45% improvement in performance. One example given was how a frame taking 16 milliseconds to render on PlayStation 5 could instead be done in only 11 milliseconds on PlayStation 5 Pro, and those extra 5 ms could instead be spent on adding a ray tracing. These additional WGPs were primarily focused on ray calculations and the divergence associated. By improving the ease of use, Mark Cerny hoped that ray tracing would continue to be adopted at an increasing rate. Lastly, Sony made a point to touch on the machine learning AI present in the PlayStation 5 Pro architecture. By utilizing ML, it's possible to give games a graphical boost by having a game render fewer pixels and then using the PSSR neural network to fill in the gaps. This was bookended with the intent that this would not necessarily result in rendering a smaller resolution to begin with. By way of extrapolation and frame generation, the possibility exists to have PSSR insert frames between keyframes and reduce the choppiness that's commonly seen in games running at a reduced frame rate. This type of adjusted rendering would not necessarily be the be-all, end-all in terms of graphical processing. Sure, the possibility exists for developers to use the neural processing units to initially render a title at 540p or 720p, but ultimately, it comes down to the matrix math, as Cerny called it, and integer operations at play, namely the tops, or trillions of integer operations per second. These tops are the real new numbers that Sony wanted to focus on for rendering efficiency and the actual bandwidth of the PS5 Pro hardware. Sony ended their presentation on the PlayStation 5 Pro deep dive by talking about the future potential for what the next PlayStation could achieve and also a unique collaboration with AMD that they're calling Codename Amethyst. While much of the machine learning architecture on the PlayStation 5 Pro pushes the hardware to its limits, there is still a bottleneck at play in terms of system memory access. This is an opportunity for growth and perhaps to achieve a fully fused network with processor and the overall potential for growth with machine learning as a whole. Through the PlayStation 5 Pro, Mark Cerny and his team have developed a good understanding of what the current system architecture is capable of and what is to come in a future console. While details are somewhat scarce compared to the rest of the PlayStation 5 Pro deep dive, Amethyst is the culmination of a unique collaboration with AMD to create a democratized library for machine learning, built upon multiple generations of RDNA and Sony Interactive Entertainment's research and development. Mark Cerny likened the potential of this collaboration to developing a sort of neural network focused on graphics for gaming. This is where future hardware architectures for both machine learning and AI would be integrated and allow developers to use these resources and perhaps guide the technology into unanticipated directions. Sony made a key point that this collaboration would be developed in parallel between the two companies, with developers having the ability to draw from libraries. Rather than this being some matter of proprietary technology solely for Sony, Amethyst is intended to bring broad machine learning across a variety of devices. It's definitely an intriguing initiative, though it's unclear when we'll see it bearing fruit in actual games.